In this video, you will learn about the Pythagorean Theorem. Now, what the Pythagorean Theorem is it's a theorem or a formula that is used only with right triangles, and it's used to find an unknown side of a triangle. And the formula is c squared equals a squared plus b squared. So for example, here we have a right triangle. One side is 3 feet, another side is 4 feet, and we're trying to find this third side over here. Now, as we begin, we need to understand a couple terms. So first we have the term hypotenuse. Hypotenuse is the side opposite the right angle. So here's our right angle. The side opposite from that, over here, that is your hypotenuse. And in the formula, your hypotenuse will always be the letter C. Alright, and then the other two sides that are not the hypotenuse are called legs. So we have two legs, and we can let one of them be A, and the other one can be B in the formula. Alright, so it doesn't matter which one is which. We can let 3 be A and 4 be B, or 4 can be A and 3 can be B. Now we can use this formula to solve for the unknown side. So looking here at the same example, using our formula, we said the hypotenuse is C, and then this can be A, and this can be B. All we do is we plug the numbers in. So we have C, or x squared, equals A, or 3 squared, plus B, or 4 squared. So I just plug the numbers in. 3 squared is 9, 4 squared is 16, so 9 plus 16 is 25. And to solve this, we just need to get rid of the square that is with the x. And to do that, we can do the inverse of squaring, which is square root. So I take the square root of both sides, that will cancel out, and I'm left with x equals the square root of 25, which would equal 5. And it's 5 because 5 squared is 25. Here is another example. We have a right triangle and different side lengths. So this side is 5, this one's 13. We're trying to find this side length over here. Well, because we have a right triangle and we're trying to find a missing side length, we can use the Pythagorean Theorem. And that says c squared equals a squared plus b squared. Now remember that this here is your right angle, and the side across from that is called your hypotenuse. And the side across from the right angle in the formula is going to be our c value. Alright, and then the legs, the 5 and the x, can be our a and b. It doesn't matter which one is a and which one is b, we get the same answer. So if we want, we can let the 5 be a, and then the x be our b. So just plug the numbers in. We have 13 squared, so instead of c, we have 13 squared, equals, and instead of a, we have 5 squared, and instead of b, we have x squared. So then we can solve this. 13 squared is 13 times 13, which is 169. 5 squared is 5 times 5, which is 25. And then we have the x squared being added. Now to solve, remember I can do reverse order of operations. So I see here a 25 being added and an x being squared, which is an exponent. So I can get rid of the 25 by subtracting 25 from both sides. That gives me x squared equals 144. And then I can get rid of the exponent, the square, by doing the inverse of squaring, which is square root. So I square root both sides. On the left I have x, and on the right I have the square root of 144, which would be 12. So x would equal 12. So the key for the Pythagorean Theorem is 1, knowing the Pythagorean Theorem, having this memorized, but then 2, knowing what to plug in. So make sure you know c is your hypotenuse, and then a and b are your legs. And then from there, we can solve if necessary. Now, we know that if we have a right triangle, then this statement is true. C squared equals a squared plus b squared. Now the converse is also true. I can say if c squared equals a squared plus b squared, then you have a right triangle. So Pythagorean theorem says if you have a right triangle, then this equation is true. The converse is when you switch the if and the then statement. So instead of if you have a right triangle, it'd be then you have, and instead of then c squared equals a squared plus b squared, you put an if with that part. So we have if c squared equals a squared plus b squared, then you have a right triangle. So what we can do is we can be given different side lengths of a triangle, and we can tell right off the bat whether or not we have a right triangle or not. So remember, C is going to be the hypotenuse, which, by the way, is always the longest side of the triangle. So we know that if it's equal, if c squared is equal to a squared plus b squared, then you have a right triangle. But the question is, what if it's not equal? What if it's something different? Well, if it's equal, then it's a right triangle. If c squared is less than a squared plus b squared, then we would say that we have an acute triangle. So if c squared equals a squared plus b squared, the measure of angle c is 90 degrees. All right. If c squared is less than, then angle c is less than 90 degrees, which makes the triangle acute. And if c squared is bigger than a squared plus b squared, then angle c is bigger than 90 degrees, and therefore the triangle is obtuse. Now remember your terms. Right triangle is going to be a triangle with the right angle, like this. Acute is with all acute angles, meaning all the angles are less than 90 degrees. An obtuse triangle is one angle is an obtuse angle, which means one angle is bigger than 90 degrees. All right, so in the next example, we are to determine what kind of triangle we have. So we are given the three sides of a triangle to be 6, 8, and 10. So remember, C, or the hypotenuse, will always be the longest side. So we can let C equal 10, and then A and B can be 6 and 8. So the question is, how does C squared compare to A squared plus B squared? Well, C squared is 10 times 10, which is 100. 6 squared is 36. 8 squared is 64. So how does 100 compare to 36 plus 64? Well, 36 plus 64 is equal to 100, which is equal to 100 on the left side. So it's equal. C squared is equal to A squared plus B squared, which means that we have a right triangle. So our triangle is going to look like this. And we have the sides being 6, 8, and 10. Now, what if your side lengths were 4, 8, and 6? What kind of triangle do we have? Well, C is always the biggest side, so C would equal 8. Then A and B could be the 4 and the 6. So A is 4, B is 6, and C is 8. So the question now is, how does C squared compare to A squared plus B squared? Well, C squared is 8 times 8, or 64. 4 squared is 16. 6 squared is 36. So how does C squared, or 64, compare to the A squared plus the B squared? Well, A squared plus B squared would be 16 plus 36, which is 52. So C squared, or 64, is bigger than 52, which means that angle is going to be bigger than 90, which makes this obtuse. So because it's bigger than A squared plus B squared, the angle is bigger than 90, which makes the triangle obtuse. So we have an obtuse triangle, which would look something like this, where we have one obtuse angle, and our lengths would be something like 8, 4, and 6. One more example. What if the side lengths are 4, 7, and 6? Well, again, the hypotenuse, or the longest side, is going to be our C value. So 7, we will let be C, and then 4 and 6 can be A and B. So C is 7, A is 4, B is 6. And the question is, how does c squared compare to a squared plus b squared? Well, c squared is 49, a squared is 16, 6 squared is 36. So how does the c squared compare to the a squared plus b squared? Well, a squared plus b squared is 52, and then c squared is 49. 49 is smaller than 52, which means that that angle is going to be smaller than 90, which means our triangle is going to be acute. So we have an acute triangle, which would look something like that, where the side lengths are 4, 6, and 7. And that concludes our lesson for today. We will see you next time.